Bismillahirrahmanirrahim. Assalamualaikum everyone. Okay, today we continue our lesson topic 1.2. But before that, I just want to do some review. Okay, topic exponent 1.1. Okay. Okay, what is exponents? Okay, basically we know that exponent is it must be in terms of x power of n or a power of n. Okay, what does we call x and a? Okay, these two we call it as base, and then the power itself we call this x exponent. Okay, our base. Okay, base must consist of r. Okay, what is r? R is real numbers. And for those who are wondering what is real numbers, it can be all numbers. Okay, I think all of you already familiar with the word of prime numbers, natural numbers, whole numbers. So to sum all of this, okay, we know that for the number that we can count, for example 1, 2, 3, 4, 5 and etc., we have decimal, for example 0.05, 0.01 or negative 0.5. And also we have fraction, okay, and also we have, for example, negative numbers and including zero. Okay, all of these we call it as real numbers. Okay, it including prime numbers, whole numbers, and then we can put all of this into real numbers. Okay, and what is exponent? Okay, exponent must be natural numbers. Okay, must be natural numbers. Okay, if you Google it, what is natural numbers? Okay, it sometimes can include zero. Okay, as natural numbers. 0, 1, 2, 3. The number that we can count. Okay, okay, this one must be exponent. Okay, a and x can be any real numbers. Okay. Okay, this is what we call exponential notation. Okay, I give you examples. For example, I have here example 1. Let's say I write a power of n. Okay, means that a can be multiplied many times, including, okay, this is what we call n factors. We do not know how many times that we can multiply. Okay, this is n factors. Okay, let's say I write 3 power of 4. Means 3 multiplied by 3 multiply 3 times. This one we can simplify and we can write as power of 4. Okay, we can simplify this expression as 3 power of 4. Okay, and then I give you example 2. Okay, let's say I have here 3 power of 2 multiply 3 power of 5. Okay, we know that when we multiply the exponential form, so what happened to the exponents? Okay, we have to add. So the answer is 3 power of 7. Number 2, let's say I have negative 2 power of 2 multiply negative 2 power of 3. Okay, what will be the answer? So, okay, since we have the same base, okay, remember when you can add the exponent when we have the same base. Just now we have 3 and then here we have negative 2 and negative 2. So, for the base you have to add the exponent. The answer is negative 2 power of 5. Alright, this is example 2. And then example 3. Number 3, let's say I have 3x multiply 3x power of 2, let's say. So if, okay, what do you think? Okay, let's say I have here 3x multiply 3x, we have the same base. But remember, okay, to solve this, you have to imagine we have number 1 here. Okay, so the answer is 3x power of 3. Okay, this is the basic knowledge lah for the exponent. Alright, where you already learned this topic in the previous videos. Okay. Okay, let's say I have here, okay, example 3. I have here 3x power of 2 multiply 3x power of 2. Okay, here, okay, for the first one I have bracket, and then for second one do not has bracket. So how can we solve this? Okay, actually this one we cannot. Okay, for example 3, can we solve like in the previous example where we can see here we have number 2 and number 2, and then the final answer is 3x power of 4. Is it correct? Okay, actually this is wrong, where we know that here we have, okay, the different expression. Okay, so you have to take note that now our base is here 3x. Okay, now for the second one, base is only for x, okay, which has the exponent we call it symbol. Okay, meaning that 2 is only for x, not for 3. So the way we solve this question will be a bit different. Okay, so the answer that I give you just now is wrong lah. Okay, for example 3. Okay, now we proceed next. Okay, now we proceed into topic 1.2, polynomials. Okay, now we proceed. Okay, this is topic 1.2, polynomials. Okay, what is polynomials? Okay, by the definition, a polynomials in x is an expression of the form. Okay, it must be in the form like this. Okay, x power of n, and then n minus 1, x power of n minus 1, and until we have here a0. Okay, this is what we call as polynomials, where n is a non-negative integer. So means that the power cannot be negative. Okay, n non-negative integer, it can be 0, and it can be 1, 2, 3, 4, okay, and etc. And then a not a1 are real numbers with a n cannot be 0. Okay, the first one cannot be 0. So now to simplify this, I give you the example for the polynomials. Okay, now we know that, okay, the power cannot be negative. Okay, so in the example I give you the positive integers, and then for the a, they said that a, okay, a means that the in front number, okay, we call this one as coefficient. So a are real numbers with a n cannot be 0. So to simplify this, we call the number in front of x. Okay, now I have example here. This is what we call it as coefficient. Okay, and 1, okay, this is what we call it as term. Okay, okay, here I already wrote this one. So what is term? Term 2x power of 5, 8x power of 3, and then negative x power of 2, 3x, and 1. This is what we call term. Term by term. We have how many terms? Okay, to combine all of this, we call it as, if we combine all of this, we call it as polynomials. Okay. Okay, what is the coefficient? The coefficient means, okay, the number in front of the x. So means negative 2, 8, negative 6, 3, and also number, if I'm not mistaken, number 1 also considered as coefficient. Alright, so this is the basic form of polynomials. Okay, now next we proceed the operations involved in polynomials. Okay, we will discuss after this. Okay, we continue for the topic polynomials. Okay, this is when it involves sum of operations, okay, involving addition, subtraction, multiplication, and also division for the polynomials. Okay, for the first example, okay, this is example involving addition where we have polynomials. Okay, firstly, how can we solve this? This question is, you have to open the bracket, okay, where, okay, now when you open it, you get 3x cubed plus 2x cubed minus 4x plus 5. Okay, this is the first polynomials. And then plus, okay, positive, you have to expand one by one, means that positive multiply negative, multiply for each operations inside the bracket. Okay, so when positive multiply negative, so we get here negative 2x cubed. Okay, positive multiply negative for the second term, we get negative 2x square. And then positive multiply negative, we get negative 2. Okay, so now you already remove the bracket, okay, for this example. So now how can we solve? You have to find the similar power. Okay, kalau Maiden nak cakap bahasa mudah, kena cari adik-beradik dia. Okay, so now we can see that, okay, now we have 3x cubed, we have to find another x cubed. So now we have here, okay, we have this one and we have also this one. So kita groupingkan dia. So kita akan dapat 3x cubed minus, okay, don't forget to bring along the sign front of the coefficient. Okay, settle this part. Now we can see that we have plus 2x square, and then you have to find another x square, so we have negative 2x square. Okay, you can just cancel that you already taken the term. And then we have next negative 4x. Do we have another x in the polynomials? Okay, no, we just bring it down. And then we have 5 minus 2. Okay, done this part. Okay, this is the, we call it as amatur lah. Okay, let's say I do it one by one. Okay, next we solve it. How can we solve? Remember, to solve very easy, where we have, okay, you don't have to meaning that let it be x cubed. We just only care for the notation. Okay, means that to solve this, you have to minus, okay, 3 minus 2, we get 1, right? So we normally didn't write 1 in front of x cubed. Okay, now we proceed the second one. When 2x square minus 2x square, we got 0. No need to write 0, okay, because of it doesn't exist at all. So just let it be. Okay, no positive. And then minus 4x plus 5 minus 2, we get 3. Okay, so this is the answer for number 1. Okay, involving addition operation. Okay, now we move to the second example. Okay, but before that, don't forget, I do some grouping before I solve this problem. Okay, where what I explained to you just now. And then, okay, for the second one, okay, this is the second example in example 4. Okay, now we have subtraction. Okay, for the first step, you have to remove the bracket. Okay, if you want to remove the first one, okay, just copy the term by term. Okay, now when it involves the operation of subtraction, you have to expand one by one. Okay, remember, expand only, okay, the operation. Okay, let's say now we have negative. When we expand, we have negative 3x power 4. Negative multiply positive, we have negative 9 cubed, negative 3x square. Okay, this is the first step. Okay, second, remember, you have to find the similar degree. Let's say we have power 4 minus 3x power 4. Then plus 3x cubed minus 9x cubed. 4x. No, we have negative 3x square here. And plus 4x plus 6. Okay, now you already cancel all. we write it for the next step. Now, okay, solve this one. 2 minus 3, we get negative x power of 4. Okay, for the first part. This is for the first part. We get x power of 4. For the second part, we have 3 minus 9. So we get negative 6x cubed. Okay, this is the solution. And then we have, do we have any other ni? Okay, this is just copy for the square plus 4x plus 6. Okay, plus 6. Okay, so this is the solution for subtraction. I hope you understand. Okay. Okay, just now we learned addition and subtraction. Okay, now for example 5 multiplying the polynomials. The first one is, now we have example 3x multiply 4x minus 2. You have to expand one by one. You have to multiply each term in the bracket. So now we have here 3 multiplied by 4, we get 12. X multiply x, we have 2. Where previously we have 1 here, and then you have to add the exponent. And then when the second term in the bracket, we have negative. Okay, 3 multiplied by 2, we have 6x. Okay, this is the solution for the number 1. And where we call this as distributive law. Distributive law. Okay, you can refer your book page 15. Okay, the law, okay, number 1. Okay, the second example is, okay, find the product. Okay, what is product? Product ni bukannya barang, tapi product in mathematics we call it as hasil darab. Okay, you have to find the multiplication of 3x plus 5 multiply 2x minus 3. So you have to expand one by one, means that here the first one, the first term, and then second term, okay, like this. So when you, this is what we call expand. Okay, expand the polynomials. Okay, the answer is when 3x multiply 2x, we get 6x square, and then 3x multiply negative 3, negative 9x. Okay, the second term inside the first bracket is 5 multiply 2x, we get plus 10x, and then minus 15. Okay, this is the answer after you expand, okay, the bracket. And then now we have to solve. Okay, find the similar degree. Now we have 6x square, 9x plus 10x. So here we have negative, we have positive, so plus x. Okay, negative 9 plus 10, we get 1, and then minus 15. Okay, this is the solution for example 2. Okay. Okay, this is example 3. Okay, now we have 3 terms inside the first bracket and 2 terms for the second bracket. Okay, now we have to expand one by one. Okay, expand 2t square multiply 2t, so we get 4t power 4. Okay, and then the second one minus 2t square. Okay, this is when you multiply this one and also this one. Okay, the second one, we get negative t multiply 2t square is negative 2t power of 3. Okay, because of here we have 1. When we multiply the same base, so the exponent we just add, so we get power of 3. And then negative multiply negative, we get positive t, the second one. And then for the third term, plus, okay, 3 multiply 2, so we get 6t square minus 3. Okay, so now we solve. We have to find the similar, okay, the same exponent. Okay, 4t power 4 minus, do we have, okay, now we have negative 2t square plus 6t square, so we have plus 4t square. Okay, how about, okay, this one minus 2t cube plus t minus 3. Okay, this is the solution for number 3. For the example 6, we have special products. Actually this is in your book. You can refer some properties in your book, but for me I call this one as special products. We have several formula for this, where we have x plus b square. How can we expand this one? There's one formula. How to expand it? First we can a square, write as a square, the first term, and then second you have to multiply all numbers. A multiply b, we get ab, and then multiply by 2, we get all of this plus 2ab. First we square a, and then we multiply all numbers, all unknown, including unknown, and then the third one you have to square b, so b square. This is how this is how I expand the expression when we see in bracket a plus b square. First it involves 3 steps. 3 steps. Same goes to negative. The first one we have to square a, and then the second step we have to multiply all, including the operation. So a multiply negative b, we get negative ab, and then multiply 2, we get 2ab. Alright, and then the third step, you have to square the negative b. So when we square negative, it become positive, and then b square. Remember this one also 3 steps lah. And then number 3, how can we expand this? There's manual operation. You have to multiply one by one. So a multiply a, we get a square. A multiply negative b, we get negative ab. A multiply by a, b multiply a, since this is positive, so positive ab. Plus positive multiply negative, so negative b multiply b, we get b square. So now we can see this one, we can just remove negative ab plus ab, so exactly no answers. 0. So a, what's left is a square minus b square. This is what we call in your book is difference of 2 square. This is two square, and then for another one is square of a binomial. This 2 is square of a binomials. Square of a binomials. Right? This is formula you have to remember. Example for formula that we discussed just now. Number 1, we have 2x plus 3y square. To solve this, you have to expand. Remember, we have to square the first term, so we get 4x square, and then we multiply all terms inside the bracket, including the exponent. So we get 2 multiply 3, we get 6. 6 multiply 2, we get 12. And then x multiply y, you get 12xy. And then plus, we have to square the second term. This is the third step, where we have to square the second term. So we get 3 square, we get 9. And then y square. So this is the solution for number 1. Number 2, let's say I have 4x minus 2y square. This one, just now we have positive, and then the second example we have negative. Remember we have to, the first step, we have to square the first term. So 4 square, we get 16x square. The second step, we have to multiply all terms. So 4 multiply negative 2, we get negative 8. Negative 8 multiply 2, we get negative 16x multiply y. 16xy. And then when third step, you have to square the second terms in the bracket. So square negative, you get positive. 2 square, you get 4. And then y square. Okay, so this is the solution, okay, for number 2. And number 3, I have 2x plus y, and then the second one, 2x minus y. Okay, so this one you have to expand one by one. So we get 4x squared minus 2xy plus 2xy. This one, the third, okay, y square. So we can see this. This is the similar term, so we can cancel out. So that is 4x square minus y square. Okay, so this applies the three formula that we discussed just now. Alright. Okay, this is our last example. Okay, for example 7. Now we have, okay, this is normally, okay, this kind of question normally we can see in the, okay, appear in the final exam. Okay, so you have to solve one by one. Okay, first we can see we have 3 types of bracket. Okay, so we have the like a flower bracket, and then we have square bracket, and we also have open bracket. Okay, so we solve one by one. Okay, 2 3 cube minus, okay, just let it be the, I call it as flower bracket, and then t square, and then I just solve what's inside the bracket. Okay, I just expand. Okay, negative 2t, negative, negative, positive 1, t square bracket plus 4. Okay, and then for the next step, 2 3 cube minus, okay, 3t square. Okay, you can solve all items inside the square bracket. So t minus 2t, we get negative t plus 1. Don't forget plus 4. Okay. Next step is 2 3t cube minus, okay, expand, negative, negative, positive t minus 1 plus 4. Okay, now we already removed the open bracket. Okay, so now we solve inside the bracket. We get, okay, this is t square plus t, negative 1 plus 4, we get 3. Okay, expand, negative t square plus minus t minus 3. Okay, so this is the solution. Alright, so you have to solve one by one. Okay, this is our last example. Okay, simplify 2 3 minus 2 square bracket x minus 2x open 3 minus x. Okay, this is the question. Okay, firstly, how can we solve this? Remember, we have 3 types of bracket here. You just copy the first bracket. Okay, now we can see that we can expand. Okay, this one. So it will be negative 2 multiply 3, 6 x, negative multiply negative, positive 2x square. Okay, don't forget the bracket. Okay, now the second step. Okay, again we just copy 3 minus, okay, you have to expand one by one. So we get 2x, negative, negative, positive 12x negative. Okay, multiply 2 multiply 6, we get 12x, and then negative multiply positive, we get negative. 2 multiply 2, we get 4x square. Okay, so next step, simplify inside the bracket. So we get here, okay, negative 2 plus 12, negative 2x plus 12x, we get plus 10x minus 4x square. Okay, now expand one by one. 2 multiply 3, we get 6 plus 20x minus 8x cubed. Okay, this is the answer. Alright, this is how I solve the problem, okay, involving polynomials. But before that, actually this one you can just put in order. I put 8x squared plus 20x plus 6. Okay, this will be the answer, the final answer. Alright, so I hope you understand. Thank you.